Robert Lee, the physics G. Robert Lee, the physics G. Robert Lee, the physics G.
Science rules.
Robert Lee, the physics G.
Inertia is a property of matter. T minus 7 seconds.
Robert Lee, the physics G.
What is matter? Matter is anything that contains mass and space. Matter can be subdivided into atoms. Atoms can be subdivided into protons, electrons, and neutrons. Now you probably didn't know that protons and electrons and neutrons can be further subdivided into quarks. Now we'll get to this a little bit later because this is quite a complicated subject. So let's suppose that this apple right here is matter. How does matter move? Matter moves by a force. Suppose right here, my palm is a force, and I smack this apple. This apple will now move in this direction. Remember that a force is an acceleration on a mass. Now, let's suppose this example right over here. We have the palm of my hand, which I will be using as a force. This stick right here will be matter. Now before we begin, let me put on my safety glasses. Alright, now we are going to strike the stick, and we're going to exert a force on that stick. And the stick did not break because the force was not strong enough to overcome that matter. But it was a good try. To further emphasize my point on forces and matter, let's consider this example. This is Buggy. Buggy says hi. This is Buggy when a force comes by. There are many different types of forces we observe in nature. Gravity, electricity, what's making this light bulb light up. Magnetism, when we have two magnets that are attracted to each other. Did I already say gravity? Tension, which is the right here. If we take this string and we pull down on it, we are creating tension on that string right there. And then earlier, in our earlier demonstration, when I struck that stick like that, the force that kept me from breaking that stick was the normal force that exerted back on my palm. Now if you remember, for every force there's an equal and opposite force. So the normal force most of the time is the force that provides that equal and opposite force. Now gravity is probably the most familiar force that you know out of the four fundamental forces that are known in the universe. Now as you probably know, gravity is the attraction between two objects of mass. Now if you go to this demonstration we have set up over here, you'll probably see what happens when two objects of mass are attracted. Now right here in this demonstration, this blanket serves as the space-time continuum. Now the space-time continuum is a four-dimensional blanket that is spread out for the entire universe. Now we probably know that there are three dimensions that we can see. We see 3D dimensions everywhere in our universe. But the fourth dimension is time. Time is relative to your place in the universe. Now if you look in this demonstration right here, I'm going to place this object of mass in the center of the space-time continuum. As you can see, that object of mass has bent the space-time continuum. This is what Einstein predicted in his theory of general relativity. That an object of mass, when placed in the space-time continuum, bends that blanket. Now when an object of a smaller mass is placed in that space-time continuum, it slides down the hill and is attracted to the object of larger mass. When Sir Isaac Newton first discovered the force of gravity, he would happen to be sitting under an apple tree. The apple came loose from the tree and fell down and hit the ground. Right at that instant, Newton knew there had to be some force pulling object to the center of the earth. Now if you look at this demonstration right here, I am going to recreate Newton's experiment. I'm taking this apple right here, and I'm going to let the force of gravity accelerate this mass downward.
Oh, die.
In 1868, James Clerk Maxwell figured out that the forces of magnetism and electricity are the one and same. Just like two opposite ends of a magnet, when they become closer and closer together, repel two electrons, these are electrons in case you didn't figure it out, get closer and closer together, they also repel. So he figured out that electricity and magnetism must be unified, and this unified force is known as electromagnetism. Electromagnetism is the force that holds these electrons rotating around the nucleus together. Electromagnetism is also the force that holds all the atoms and molecules in my body together. Electromagnetism is also the force that, even though gravity is pulling down on this gun into the palm of my hand, the electromagnetic force in my palm, the electrons are repelling against the electrons in this gun and keeping the gun from going through my palm. The electromagnetic force is many times stronger than gravity because of this.
Jimmy is going to make an electromagnet at home. All he needs is a nail, some thin cloth-covered wire, and a dry cell battery. He wraps the wire carefully around the nail. Now he connects the ends of the wire to the two posts of the dry cell. Then he touches the nail to the clips. They hang on in bunches. Jimmy has made an electromagnet.
The two forces we have talked about thus far, gravity and electromagnetism, explain everything that we see or feel in our universe. But when we look inside the individual atom, we know that there must be other forces in play in our universe. When we look inside the nucleus, we have two subatomic particles. We have the neutron and the proton. Now when two protons get very close together, like so, the electromagnetic force wants to drive them apart. But of course we know that's not what happened. So therefore there must be some force that has happened inside the neutron that keeps those protons together like so, and overcome the electromagnetic force. That is the strong nuclear force. Now we've talked about the electromagnetic force, gravity, and the strong nuclear force. However, there's still one phenomenon we have not accounted for. Now, by the 1930s, scientists know, and we know, that a nucleus is made up of proton and neutron, and that electrons orbit around the nucleus. We also know that a nucleus decays, and this source of radioactivity actually comes from within the nucleus. Now, when a nucleus decays, an electron is emitted from that nucleus. However, we know that there are only protons and neutrons inside that nucleus. So how does an electron release itself from a nucleus? Well, a scientist figured out that a positron, which is exactly similar to an electron in every single way except it has an exact opposite charge, is released from that nucleus. Now, when a proton decays into a neutron, or a neutron decays into a proton, positrons and neutrinos are released from that nucleus, and that is how a nucleus decays. And that force is called the weak nuclear force.